Okay, so anyone has questions, anything? Okay, we started yesterday the critical part. So have you done the setup thing? Anyone has any problem in the Spark setup? Because that is very, like, it's must before starting the coding. Like, anyone has any problem in the Spark setup? Have you done the setup, the Spark setup? It's very simple one, right? I showed yesterday, right? You have to download and just set the Spark home bin path, and then you can test your Spark shell. Have you done that or not, right, guys? Please speak, right? So I will come to know, right, you are doing or not doing, right, something. So are you doing parallel with the previous things you are doing first, or what you are doing, right? Or parallelly you are not? The video I know, right, I uploaded yesterday night only, right?
Yeah, we are doing parallelly, Arvind.
So what I'm saying is like whatever previous thing is there, the pending things you can do it later also. But whatever I'm doing current, right? So do parallelly current, right? So setup is because yesterday only one practical thing was there, only setup, nothing was there, right? So if setup is ready, then only you can do start anything. And setup is I'm saying even if your Hadoop and Hadoop component are not installed, that is not a problem, right? Spark you can directly start, right? So only thing is you need a Ubuntu and VirtualBox. If your Ubuntu VirtualBox ready, you can start Spark. You don't need to depend on the previous Hadoop component. Okay. So something you missed it or something is not completed, you can plan it in the weekend. But do parallelly this setup things, right? Because I'm telling you, if this setup is ready, then only you can do practice. Otherwise, practice you can't do. Right? Okay. So it's a very simple setup things I told, right? So because today I'm going to tell about PyCharm setup also, right? Okay. So this all setups is needed. Okay. So next I'm talking about the PyCharm setup also. Yesterday we done only this Spark setup, right? The command line and the Spark submit. So two things we can do, okay, with the Spark setup, like command line shell, right? PySpark or Spark Scala shell, and another one is um, we can write a code in the PyCharm editor. So that I'm going to tell today, okay, how to set up the PyCharm. So PyCharm setup, right? You want to do first we need to download the PyCharm community edition. Okay, so if we go to PyCharm community edition download, if you see here, if you are going to do for Windows, Unix, Ubuntu one, right? So you can choose the Linux version. So this tar file you download it, and this tar file you once download, you keep it in your home directory, software directory. So you copy into the software directory. You remember, right, IntelliJ how I did, right? Same way, this PyCharm you have to copy it here. Okay. After extracting PyCharm, you have to copy it here, go to the bin directory, and here okay, so so here we go to the PyCharm folder, and here we have to go to open terminal, and you will find here pycharm.sh. Okay, so dot slash pycharm PyCharm.sh. So once you start this, it will start your PyCharm ID. Okay. Same like you did IntelliJ idea. Same you have to do PyCharm ID. So this is your PyCharm ID. So once it will be set up, right, I'll tell you how to create a project and everything. So PyCharm ID, this is a PyCharm ID. You can write a PySpark code. So can you see this? This PyCharm ID. So PyCharm ID is going to initialize. So in your case, there will be no project, right? Because it will be empty. Okay. So you have to, you can create a new project, or you can file new project, right? Suppose I want to create a new project. So I can choose the new project option, and I say this is my PySpark project. So it will, okay, so you should have already Python also. You install Python. Okay, so Python you install before this Python. So when you are set up the Spark, right? So Python you can install, right? There is a pip install Python command is there. So I'll give you the command, that one. So I have already done. About the installation of Python in Ubuntu. Windows also you can do. Windows there is a exe you can install Python, but here is a we have to install through the pip command. So pip install command. If you have not installed pip also, there is sudo apt get pip is there. So when you install the Python, so this is the steps, right? So we have to sudo apt update, sudo apt install Python 3. Okay, so this is the Python you can install through apt or using the pip. The better is you can use this one also, sudo apt install Python 3, and then Python 3 version you can check Python 3 version. What is the version of the Python 3 you install? So you can check here. See 3.8.10. Okay. So my Python is a 3.8.10. So don't go much higher version, 3.8 version, because these are the stable versions. So install that stable version. Okay. So in the PyCharm, like it will automatically take your Python, because this Python will be installed in the user win directory. So it will take your Python automatically. Okay. Because whenever you installing Python sudo apt install Python command, so it will go to the user bin directory. Okay? So it will take it your Python automatically when you're creating a new project. And when you create a new project, so it will create a one empty project. So here is the option, this window or new window. So this window is like if you have already opened any previous Python project, so you can, like, you don't want to like override on that, so you can create a new one. The two windows are there. So one window is for my previous project and one window for my new project. So here now I created a new project. My project name is PySpark 1. This one is a PySpark 1. Are you able to see? So this is the PyCharm ID. Okay. So here I'm creating a project. I created a project PyCharm, and here this is the one default file they give, like just sample file they given. If you want to run this, right click on this, and you can run. Run file. So this file just printing the hi and whatever the PyCharm, hi PyCharm. Okay. So this is the main function is there. Even if I remove this one and directly call my function, I can do. So main function is not mandatory, but when we are writing a PySpark code, we have to write. So can you see here? So hi PyCharm is coming. Okay. So if I don't use this main, simply I'm calling my print hi function. Very alignment is very important. Otherwise, it will be missing. So if I'm running now, So this function will be called the same. This function is called and giving the output. This function is giving output is this one. So if I want to create my own Python file, how to create? Or PySpark code I want to create, the new and then Python file. Suppose I say I want to create some Python code, like some PySpark code. So PySpark code is nothing but your Python file only. Okay, so test underscore spark dot py. Okay, so I created a one file. Suppose I want to run some PySpark code in your empty project. Okay, so I take the simple example of this here. So this is completely GitHub code, so it is directly imported. Okay, so this is directly all the files are coming here. So it is directly imported from the. So suppose I have some CSV file is there, and this CSV file I'm reading in the some folder, right? So PySpark example folder is there. So this PySpark example folder having, okay, here is, this will create a problem because this is a C drive. This will not work. This one we are reading the CSV file, so I'm just giving a path of the file. Okay. So first I check this session is able to create or not. Okay. So I'm just going to create a this session. When I go to my new code, it will give me the error. Why it is giving me error? Because this library is not recognized, because this is a Python project. This is a Python, okay, file, but it is not having the library of the Spark. So what I need to do, whenever you create a new project, you have to go to settings and two libraries you have to add. You have to go to here in the project structure. Okay, the project structure, you go here and add content group and go to the where my Python is stored, right? My Python is in the software folder. Okay, so I go to my software. Software's having my Spark. So my Spark is 3.3.2.3, and there is a Python. There is a Python and there is a lib. So there is a two libs are there. These are the two zip files. These two zip file I will select it and I will add it. Like this is the initial setup you have to do. First, Okay, let's restart this project again and open it. So I recent project. Okay, recent project means I just created recent. Like click here, the new window. Okay, so now if you see this is Spark session is created. Okay, now we run. Actually, you have to restart. Okay, now it's not giving error. So now I have got it. My Spark session is like created. Okay, if I print or any Python code or Spark code, I can run. Okay, so I can create some data frame or RDD from any code we can do. Just I'm taking this data and creating a data frame. So let's see this data. This much this code. So for testing purpose, you can understand that this code is working on. So here is the column names are there, data is there, and I'm just creating a data frame out of data and columns. Okay. So if I run this code, so you can take it example from your this another one and paste it here in your new one. Can you see? Like output is coming, right? So this is giving a data frame, and schema is basically what are the columns are there and type of column. So one column is your array type. This column is an array type. So array is coming. And this column is a string type. So string is coming. And the first column name is a string type. String is coming. Okay. So this kind of examples. So I will show you some examples of RDDs and data frames. So yesterday we were talking about, okay, when we are talking about the three data structures, right? So we started like transformation. So transformation we'll see, but before that we have to understand what is the RDD data frame. So these are the main data structures of the complete Spark. Okay, RDD, data frame, and data set. So mostly we will be working in the RDDs and data set. So data set is the other special use case where we use entity-based object. So then we go for data set. RDDs and data frames. So even RDD also we don't use. We 80% we use the data frames because data frame is a tabular representation of the data, and most of the times we are reading the data from the different file format data. So I told you if you are reading the data is from the text file, and that is the unstructured data. Okay, so that will be always the RDD. Okay, and we go row by row transformation. Row by row transformation we apply. Okay. But here in the data frame, it is data is structured form. Structured form and data is coming with schema. Structured form schema. Right? So schema, which kind of data formats are the schema based? Like CSV file, JSON file, okay, Avro, Parquet, ORC, okay, and XML file. So these are all schema based structure, right? A fixed schema is there. A certain number of columns are there, and converting, it is converting into the, when you are getting a data frame, you will be getting a data frame of row and column, rows and column representation. Row and column is nothing but a table, a table. So you can apply your transformation. So here you are applying the transformation row by row, and here you are applying transformation, applying column by column. So column by column you are applying the transformation. So suppose I say, give an example. I have a one ID column is there, one first name is there, one last name is there, and one city column is there. I want to say you like I want to do the transformation. You take a first name column and concat last name. Okay, like some space will be there, and say last name concatenation last name, and create a one column full name, and add this full name in your data frame. So how your data looks like: ID, first name, last name, and full name, then city. So this is the example of data frame transformation. So you are using the first name and last name columns, and you are applying the like you are creating a one full name column, and you are adding this full name column in your existing data frame. Right? So this data frame, suppose I say this data frame is a DF. Suppose you read a file, you read a CSV file, and you get these four columns. And this data frame, after applying the transformation, you say DF1. So when you're creating a new data frame, if you want to overwrite, you can give the same name of the DF. Like this you write. So what it will do, it will override in the this 5 columns data, it will write back to the 4 column data. So if you don't want to use the previous one, so always you should override by giving a same name, right? You know, right? Suppose I have a one X variable is there, okay, and I say I'm assigning the another variable Y in the X, right? So you know, right? X value is replaced by the Y value, right? So if you don't want to use further X value, the previous value, right? So you can override it. But if you think, okay, this DF I want to use for some other purpose, so don't override it. In that case, you keep it a new data frame. Okay. So might be any other transformation you do in this DF, and you create a DF2. Suppose you say, I want to create another DF2 from the DF1, right? So DF1 you created from the DF, and DF2 also you are creating from the DF, and you want to find the city, a particular city name you want to find. So which transformation you will apply? Suppose I say I have a city. Okay, I say X city data is there, X and Y city data. 2 cities data is there, X city and Y city. Okay, so X is a one city and Y is a one city. I want only X city data. So which transformation I will apply here? Like when I create a new data frame, so which city I will apply? So I will write df dot filter, and I will see city equal to X. Very simple. If I write like this, what will happen in this? It will come, df2 will come, only city is, it's like a where clause. It's like a where clause, right? So this is a data frame API operation. These are the data frame API operations, like string operations I'm doing, filter operation I'm doing. So these are data frame. But the same operation, if I want to do in a SQL, so what I will create? So this data frame df, I will create a table. I will create a one SQL table, create or replace time view, and then I will give the table name as P1, some table name and this. So this is not exactly table. This data frame is a representation of the table, but not exactly the SQL table. Okay. But when you use this df dot create or replace temp you do and P1 you give, then it becomes a SQL table. And now you can do the SQL query. Now you say, I want to get another data frame 3, spark dot SQL, and write a SQL query on a data. So how will you write? Select star from P1, where city equal to X. So same thing, whatever you can write by using the data frame API, same thing you can write with the SQL. Because SQL query when executed, the SQL query is executed here and it will be giving again data frame. So again, you want to create a SQL query. Again, you have to create another replace time view. So this is kind of process, right? Creating a SQL, but generally the SQL we go when the complex query is there, right? Now df3 dot create or replace time view is 3. Now you have this df3 data is only city X. Now you want to do something which is on the city X data. Then you can write another SQL on this. You can write df4, you can say df4, and you can write a spark.sql and you can write now T3, right? But something else you will be doing, okay? So because already you have done the city X data you have. So this is kind of like, suppose you want to do 2-time filter, so you can directly write filter directly end condition here, right? So it's no point like 1-time filter you done and now you say where last name something like operator you are using, say start with, right? Something you say percentage, you say AGG, something is there, right? To the last name. Only those last name you want to filter, okay? So this filter you can apply it itself here, right? You don't need to create a table. So ultimately you are filtering the data, again you are filtering the second time data, right? Okay. So generally the transformation we decide, like if the similar type of transformation we are doing 2 times, right? So I can merge it with the 1 time and then I can do some group aggregation type of transformation, right? Which is, okay. So as much as transformation you can do in a single query also, even group query, any query you can write, not only one single transformation. You can do a lot of transformation you can do. You can say, I want to find first name and some count star you want to do. Okay, count star you want to do. Based on the first name, you want to do the count star, right? So, and group by you are doing here. Group by, you are applying the group by query, group by first name. So SQL, the advantage is you can write as much as complex query you can write. But when you are using a data frame API, at a time you can do only one filter, right? Suppose I'm doing a one filter and then I want to do group by, I can write a separate group by API. Now same thing I'm going to write here. Okay, if I'm not going to use SQL, if I'm going to use data frame API. So in the data frame API, I'm doing city equal to X and group by I'm doing the first name and then I'm going to do dot select and then I'm saying first name, comma, name I do. Count. So I can do, I can even simple count also because it is count only because it is. So when I'm doing this one, so I'm getting the group by and same thing whatever I'm doing here, same thing I can do the data frame API. So whatever result will come, that will be coming the final result. After applying these all transformations, then I will get the final result in this. Okay. So transformations when the trigger, right? When the transformation trigger, right? So it will, when the action is triggered, then only transformation will, you will get it. Okay. Is it clear? This one, right? This is just I shown to you, right? What is the data frame API and what is the Spark SQL. So in the most of the examples, right, we will be using either data frame or like SQL, either Spark SQL or data frame API. So depending on the scenarios, we use SQL or data frame. Okay, the one first program we understand how to do the RDDs, we understand first. Okay, let's see RDDs, right? So so RDD is like, I told you, either you can read a file, then you can get RDD, or you can use a parallelize function and you can have any collection. you can get RDD. So if you can read any file as a text file, you are reading any text file, you will get RDD because it's an unstructured data. Or you have some collection like this collection is there, and you are applying in the parallelize function, then you will get this collection will become a RDD. So what is the difference in this RDD collection or this collection? This RDD is the parallelized, like it's a distributed, but this collection is not distributed. This is just a simple Python collection, right? List, right? But when it becomes RDD means it is distributed. Okay, this is a small collection, but I'm saying if it becomes a large collection also, it will be distributed. And when I'm just doing, there are the count is the action, it's not transformation. Okay, so here I'm just reading, I'm just making it parallelized and just calling the action, but I'm not doing anything as a transformation. But suppose if I want to apply the transformation, so I say RDD1 equal to RDD dot, suppose I want to do filter, and I say, so filter, how I will use, because this is a list of elements are there in the list, right? Elements are there in the list. So I say I want to find the element lambda x, which number are the divisible by the 2. So how to do x %2, like even number, okay, equal 0. So if I say the x value, each x value, which is percentage I'm using, modulus, right? Modulus operator. When I'm saying x %2 is 0, so which number will come? 2 will come, 4 will come, and 56 will come, right? There is the remainder is 0. And I want to find the count of those numbers. So what I will do, will say RDT. If I want to print those numbers, one dot for each, again I will use lambda and print x. I want to print those x because it is filtered. It is again filter doing, right? So I have a 5 element. After applying my this condition, okay, after applying my that condition, I will get 2, 4, 56, 3 element in this RDD1, and this RDD1 dot for each, it is an action. I'm calling the action and I'm getting the result. Or RDD1 dot count I will do. This is also action. It will be getting the value is 3. This is a Spark session printing. Okay, this is a, because I'm just printing the Spark. I'm writing the Spark session value. Spark session is printing. So you can get 2. Okay, 2, 4, 56. So 2, 4, 56. 3 numbers are divisible by 2. Suppose if I ask you if I want to find odd number, so what I should do? There are 2 ways to do this. What condition I should change? Can you guys tell me, like, first way and second way? Like this equal 0.
Modulus is 1.
Okay.
Yeah.
Okay, this is the 1. Can you tell me other one?
Or
Okay, even number comes by equal 0, right? Correct.
or x minus 1 modulus 2 equal to 0.
So this is giving even number, right? Equal 0.
Yeah, yeah.
So how I can change it? It should give the only odd number, except that 0 to 1. I don't want to this 0 to change.
X minus 1
Minus
percentage.
1.
X minus 1 percentage 2 equal to 0.
No, what? Why minus 1 you are saying to me? I don't want
If
to
it's
change the number, right?
okay.
Like you are trying to make it this 1 to 0, 2 to minus 1 number. I don't want to change. See, simple is if you put it not equal to 0. So other than not equal to 0, right? That will be odd only, right? Because I'm
Yes.
saying even is 0, so other than 0 will be odd only.
Yes.
Definitely
Yes.
it will be 1 only. Definitely it will be 1 only, right?
Yeah.
Because remainder is okay. So because when I 2 divide either 0 or 1, right? So you see still the coming same, right? 1 and 3. So this condition you say either not equal to 0 or you say equal 1. Both are same. Okay.
Yeah.
Okay. So if I'm printing this printing things, how it is happening? This for each. If I do RDD1 dot collect, that is also action. RDD1 dot collect. Okay. So this collect also will be showing you the result, but it is showing as a array type result. Okay. You cannot. So this will be coming as a value. Can you see this is now coming as an array? Actually, if you don't print it, you can't get it. Print means just bring it to the console, right? So when I'm doing RDD1 dot collect, I'm going to get as a array, like array. So as a array, you want to use it, use the collect. If you don't want to use as a array, like you want to use a separate value, you want to use it, like print it. So you can use the for each. Okay. Okay. So did you understand this one? Okay. So filter is there. Okay. One more transformation I do, you will understand like how it will work. So I do RDD2. I'm going to do RDD dot map. Okay. Map is a transformation. This map is not your key value pair map. Actually, one is a collection map is there. Okay. But in the Python, that map is called dictionary. Okay. But there is no map collection, right? Java and Scala, we have map collection. But in the dictionary is a map type. Okay. In the Python. But map is a function. This map is a function that means you want to apply anything on your each element of your RDD, anything you want to do. Now I want to say my whatever type of filter you done, similar way you do some operation on each element. Filter is just applying the condition on your each element and filter the values. But map is applying the some operation on your each element and giving you the same number of elements. It will not doing less or more element. Okay. So can you expect, right, if I do this collect, how many values should come in there? If I do this. Yes, you understand what is this? X multiply to what it will do?
It'll multiply 2 to all
All the
each
elements
element.
at each and every element. So can you tell me how many elements will come in this RDD to the collection?
5.
1, 2, 3, 4, 5. So what will be the value?
2, 4, 6, 8,
Yeah.
and 112.
56. Yeah, correct. So it will be multiplied. So I said map is a function that will be giving me each element of RDD multiply that operation, right? If I'm doing X multiply 2 or X plus 2, so whatever operation I do, I will get it. Can you see? This is the same number of element it is written. So map is transformation and it is called higher order function, right? When one function is taking another function as a parameter. So map is a function and lambda multiply, this is also anonymous function, lambda, right? Lambda is anonymous function without any name. Okay. So when I say function without name means I'm not writing any some function. So this logic, if I write in the def function, I say multiply 2, okay, like say def multiply. Okay. I'm just replacing lambda to that particular thing. Okay, so you will understand the multiply 2, multiply by 2, and I say it is taking some input parameter. Okay, and I'm going to do return x multiply 2. This function, if I pass it here, it's the same thing I was doing, right? Just I represented x, every x is a lambda x, right? But here I'm not using lambda. Instead of lambda, I'm manually calling the function. The same result is coming. It's the same, right? So lambda is giving us same anonymous function. You didn't define this whole code. Instead of that, what you did, simply if I write with the lambda, how I written. So I written x multiply 2. So it's very, very short, right? Just this logic I have written here for each x. Same thing I'm doing here, but I'm not defining any function. So I replace the function name as an anonymous function. That is the reason I use lambda. So instead of using any function name, so small short logic, right? You can define with the lambda. So that is a very easy way. Unnecessary, you create a function, call the function, right? So that is easy way. But both results are same. Either you call function or you can use lambda, right? You can. Okay, so some more transformations, right? I have a list of string values are there. So I say I have, actually I want to show you the flat map. So you will see the difference of the map and flat map. String array. String, right? With the one string and another string. Like this, I have a list. And now this list, I want to apply the flat map. So if I do parallelize this list, I will pass this list. When I pass this list, now it will become RDD, because before making RDD, you can't make it any of it. Okay. So you know, right? This map, flat map, these are there in Python also. Same way we use Python, but here is the distributed, because here map and flat map I'm applying when I'm making it RDD. Then only I'm applying. But map and flat map is directly in Python also. This map, flat map, filter, all already there in the Python. But that is not distributable, right? So we don't need a RDD for that. We need simple, any collection is there, we can use it. Okay. So this map, flat map. So I will give you the examples, like how you can see this Python, this map, flat map. Okay. But here map, flat map, filter, we are applying on the RDD. So first I got a list, and this list I created as a RDD, list RDD. And this list RDD, I'm going to create another flat map RDD. The flat map RDD, and this is a just variable name, RDD. And what I need to do, I have to take it, my list RDD dot flat map function is there. Again, lambda, every time you have to use lambda, right? If you are going to represent each element of your RDD. So lambda of x. So x means what I'm going to take this x means, like this is the one element x, this is the one element x, right? That I'm taking x. So what I need to do, flat map means like I want to make it flattening of the all the arrays in a one single array, right? all the word of different array into the one single array. So how I can do it? X dot split. So first I need to split. So what should be my split? Space, right? Because space is there. If you see in the array, each array, you see the space is the delimited character, right? So I'm splitting and I'm creating a flattening I'm doing. So every transformation is giving again a RDD. Okay. So this is initial input is RDD, and after flat map also I'm getting a RDD. So if I collect, if I do collect on this, print flat map RDD dot connect. So what is the difference you will find between the map and flat map? So what is the common difference? Like what is the difference? So you can see here, you are getting a one single array with all the values, right? Hello, how are you? I'm fine. All these words are coming, right? So why we need this flattening? Okay, first of all, what is the difference between the map and flattening? So map is always doing operation each element of RDD and giving a same number of elements. Did you see that? Like when I'm giving a 5 element, I'm getting a 5, right? After the map, I'm getting the same number of element 5, right? There is no change. Just number of elements are same. Operation is applied and number of elements are same. But when I'm using a flat map is giving the more number of elements present in the RDD. If I say here is 1 is there, 1, 2, 3 is there, 3 elements, and now you are getting more than 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you will always get more, because when you combine all the arrays and make it a single value, so definitely it will become more, right? Correct. So definitely if single word will be there also, it will be 3, right? Correct. At least 3 will be there. Equal to will be there, right? But I'm saying equal to is a one condition, but it can be more than equal also, right? So 3 is the least one, right? So if I say at least one word is there in these 3 string, so definitely it will be a 3. So flat map is giving the number of elements either equal or more. Okay? So always it will be more. Okay? So that's the main difference between the map and flat. Okay. But why we need flat map? Now question comes, okay, I need flat map and I need map. So map, I will say, I have to do something which is applied every element of the RDD. So that is the map. So you can think of any time, suppose I have on this words are there, I want to make it capital. So what you will use? You will use map or you will use flat map, or you will use first flat map or then you use then map. See, flat map you will use when I say I need all capital, no matter in, like I will get a single array. If my requirement is this, I want to all word in the capital, no matter in which string it is. Okay, I need all words in a single array, capital. So I will go flat map first and then I will apply map. Okay, or even if you go map first, then what will happen? If you make it capital map, okay, so if you go, this will become capital, this will become capital, and this will become capital as per the like upper function, correct? And then you will apply flat map, you will get all word in a single array. So there is no difference, either you go first flat map and go upper, no difference, right? But if I say I want to get only whatever string is there, string wise capital I want, then I will not go to the flat map. I will go just only map, because it will pick first string as a one element and apply the upper second element. So it's very simple, like you can call the upper function. So how will you use it? Just you use any map function. So suppose this list RDD you want to, you say here list RDD map and you say each element x dot upper. So if we use as a function. Or function. Actually, function is a library. Okay, so from I have to use, but I need to tell what I want to use. Upper is there. One is a define the constant there. Lit is there. If I want to define something like split, I want to use. Okay, split means like I want to break, right? Some string. So now upper I'm going to. What I'm doing here, I'm taking each element of RDD and applying the upper and getting into the new upper RDD. Now this upper RDD, I want to either collect is just a simple way I want to bring it upper RDD. There we go. Want to do only string specific capital only, so you don't need to go for flatness. But if you want to go for also drop at what. Okay, so this string has become each word capital, right? Uppercase. Okay. So suppose I'm asking to you, I want to do the word count of this, right? How many times hello is coming, how many times how is coming, hi is coming. Okay. So this is my list is there. Okay. So I have some list. Okay. So now you tell me I'm giving you this is a string list, right? This list. I parallelize it, I got this list already. So now what I should do first? Okay. List already got So which transformation I apply first? Flat map I apply or map I apply?
Flat map?
So what I'm going to do with flat map? Suppose I have a string like this.
Yeah. So if you have them individually, then as each element, then later we can compare and keep count to something like how many words are matching.
Okay, so you are saying flat map I apply. First I make it to bring in the single array because one word count means no matter from which string it is coming, right? Finally, I have to do every word count, right? Okay, like how many times this particular hello is coming, how is coming 2 times, R is coming 1 time, U is coming 1 time, M is coming 1 time. So I need this count. So first of all, if I bring, so here you will understand the flat map is important, right? So flat map is important because if I do apply map, so I don't need any point. How many number of strings are there? I can apply the map and I can do the count. Okay, but here I need a word count, right? Each individual word count. So I apply the flat map and I do x dot split and I do space. Okay, and remember this space now don't make it a single space, right? Otherwise now what it will do, it will character by character it will do. Okay, so this is you give. Okay, and now I will close it. So I have applied one transformation. What should be I do? So this result is this array will come. Okay, this result, right? This result. Okay, this array will come. Now next, what you tell me, right? What I will do in this array? What should I do? Which transformation I apply? Okay, generally word count, what you do in MapReduce, you tell me what you do, right? You have some list of words are there. So generally, what is the strategy of the word count?
You check how many times the elements match each other, but I'm thinking we do a map, but then I'm not sure what the lambda would be to keep the count of the words, like how many of them
So you are saying if I want to do this thing in the normal Python, so the easiest way doing this list of word is there. You will get already list, or maybe you got a string, you splitted the string into the list of word, and you can use dictionary there. So what you can use, you will check in the dictionary if word is not there, so you will give the first time one count. If word is there, so you will get the existing count and increment plus one and write back again. So finally, when you print the dictionary, you will get the result. So that is normal Python you are doing. But if I want to do the same thing with the transformation functions, right? Like step-by-step functions I want to do. Okay. So parallelized way, right? Where when I'm using the Spark, right? So Spark, I want to use it. So first I did flat map, so I will get just this kind of list, I will get it. Okay. Because flat map, it will do flattening of all word in a single array. After that, I will apply map function and say each word I will take it and say x comma 1. You remember, right, in the MapReduce we did this. That's a masking. So MapReduce, same thing we are applying here, MapReduce map type of function, right? MapReduce also having map function, right? Okay. So this map, what it will do, if I print this one, if I do dot collect, okay, I'll show you the result of this one so that you will understand. So I will say print here itself. It will print me the result of this. Okay. So if I run this, so first it will be making it one single array and each word one count. So you will get a pairs. Every word one pair you will get. Are you getting the word pair? So one is a hello one is a how one, R1, right? So initially we have to do this because every word is itself is a one count. Now I know this one is a one count. Okay, I remove this collect. Now I say which function I should use now that can do the aggregation of the word by key. So group by is there, group by key and reduce by key. Any function you can use. But I will tell about reduce by key is better. Reduce by key. So reduce by key, when you use the reduce by key, so you will use a lambda, and lambda you will give two parameter x comma y because you are doing the sum of two values at a time. So x plus y. So what it will do, it will take this hello one and another hello one is there, so it will do. Suppose this how one is there and this how one, same key, it will do how comma 1 plus 1. You remember reduce function in the MapReduce, same thing is a reduce by key. Okay. So here, if I do this and after this I will write collect, right? So what result I will expect here? it will be final done, right? It's a word count. So now I'm getting aggregation I've done, right? Reduce by key is doing aggregation. This is also transformation. Okay. So now, can you see here? These are the correct word count, right? So you are getting the correct word count, right? If you want to print it, this is coming in the array because whenever you use collect, it will come in the array, but you don't want to get in the array. So what you can do, you can assign it to another RDD. So suppose you say RDD word count, and you will assign, you remove this. Now this one you can use for it. Okay, because if you want to print individual value of array, okay, array of RDD, so you can do dot for each, and each x you want to lambda x and print x. That we have done on this side. So now you will be printing this. So you will get as a single value of the word count you will print. Okay. And the same thing, this RDD you can write into the file also. So you can write into the output in the file. So you can write into the file like this way, the output will go into the file. But there is a one space there. So this word count is basically the count of the word in the array. Okay, but before array it is a string, like list of string, right? Or only single string also work fine. Okay, if I make it one single string, like suppose mine, so this will also work. If I do this will also work because it's a single value list, right? It's nothing matter, right? Whether it's a single value list or it's a multiple string list. So my output will accordingly will come, right? Whatever my output, right? So now output is coming for single string is there. Okay. And this data, if I read it from the file, suppose if I read the data from the file, same operation I will do. Because either I'm reading the data from the file or I'm creating the data manually, it doesn't matter. Both the data will be RDD. So if I'm reading the data like this file, reading the data directly as my collection, but if I read it from the file like spark context dot text file, and I give the file name, so I will get also the same RDD, and this same operation I can do that. Okay, so I can read the data from the file also. Okay, so any file type of operations we can do in the RDDs. We can read any file also. Like this data.txt file. Okay, so if I want to read this this is the text file, right? And this is the unstructured form of data. So this data.txt file, if I want to read here in my this example, or the start context, the text file, then I give the path of the file. It is in the resources folder. I'm not using the palette. I just do Maybe the file location is a CD copy. This is some path probably. So this is okay. So it is understanding it is a Hadoop font. Okay, because here it is saying connection diffuse. So it is trying to read. So we give with the local path this file colon slash file colon. Related path also. We don't need to give entire path. File colon. Slash for the home node. So I giving the absolute path, like complete path I give. I can give the related path also, like project related path, like PICE path and this thing. Because project related path always can be read, right? Whatever files are there. See, these are the file are there. Okay. Let's see control set power. See, like this we can src dot main dot resources. Resources on this code. Right, this file. How they are reading this file? They are reading resources. No, the same thing will be. It's not so. Okay, so are you able to see how many rows count is there? 5 is coming, right? Now it is able to read the data from the file, right? It is able to read uh, data from the file from basic sensor. This one. So we are getting the 5 rows, right? The 5 rows are there. If you want to apply the same thing here, where is that? The word count for the same. Okay. I want to do for the file one. Okay. So whatever my file RDD is there, this RDD file I will pass it here, right? So this RDD file I will give it to this, and then I will get it. I will give it some different name, RDD1. So now I can print this file word count. Same logic, right? Only thing is how you can read the file. How different way you can read the file. So you are reading a file, and then you are applying the same flat man and reduce cycle. See, these words are coming from the file. If you see the file, these word in the file data.txt. Can you see this? Project is 3 times, 1 time, 2 times, right, and 3 times. Project is 3 times. Advances is 2 times. In is 2 times, right? So this is same word count, nothing different. Okay. Okay, I will share this particular file so that you can do practice, okay, on this code. And this code you can find from this example. So how to check out the code? So you have to this string by spark PySpark. So this is the complete source code. This source code you want to check out. So copy this one and you have to, you can check out a new project. So in that project, pick option. Okay. So when you start the new one, so I have told you the new Git project and GitHub project also you want to do. There's the option BCA. Git from the version control. Can you see this option? Git from the version control. Paste your URL because mine is already this project is created. So it will give me the error because I have already checked out this project. So if I make it one, then it will create a new project name. Right? But in your case, you don't need to give one. Just run this and clone. You will see your entire project will come like this. The one project, the PySpark example project. Okay, the entire big project will come. That will then you have to add the library content. This too. Okay, sort out any issue comes, I will see, right? If anybody is having any issue. Okay, and I will send the source code. Okay. Okay, thanks everyone.
Okay, see you.